In this problem, we need to resolve the given rational fraction into partial fraction. So let us begin. Now clearly, if we consider the denominator of the given rational fraction, we have three factors. One is x plus 1. The other two factors are x squared plus 1 and x squared plus 1 is repeating here twice. Okay, so here what we'll get is three partial fractions. So we are going to represent the given rational fraction x squared divided by x plus 1 multiplied to x squared plus 1 whole squared as three partial fraction. The first one being a over x plus 1 divided by the second partial fraction. We'll come to the numerator in a moment. We have x squared plus 1. Now x squared plus 1, that's a quadratic factor. So that means the numerator is going to be of the form bx plus c. However, x squared plus 1 is repeating twice, so we'll again have to consider a third partial fraction where the denominator is going to have the factor x squared plus 1 whole squared. Then again, x squared plus 1 being a quadratic factor, its numerator is going to have something of the form dx plus e. So this is how we can resolve the given rational fraction into its constituent partial fraction. So that means we'll have to find out the value of a, b, c, d and e, the five unknowns, and that's going to help us obtain the required partial fraction. So let's begin. We're going to begin by labeling this as number 1. So what we'll do, we'll take number 1 and multiply throughout with x plus 1 times x squared plus 1 whole squared. So let's do that. We're multiplying both sides with x plus 1 multiplied to x squared plus 1 whole squared, such that we get x squared on the left hand side, and on the right hand side we will have x squared plus 1 whole squared multiplied to a, plus we have x plus 1 multiplied to x squared plus 1 times bx plus c. Then we have x plus 1 multiplied to dx plus e. Fine. Now what we'll do, we will expand the right hand side and we're going to combine all the like terms. So here we will get the highest power of x will be x raised to the power of 4. So its coefficient is going to be a plus b. Then the next, the lower power of x in the descending form will be x cubed. So its coefficient will be b plus c. Then we have x squared, whose coefficient will be 2a plus b plus c plus d. Then we have x with the coefficient b plus c plus d plus e. And then we have the constant term, so that's going to be a plus c plus e. Fine. Now here we can observe that there are in total 5 terms. So here the first term contains x raised to the power of 4, then we have x cubed, x squared, x and the constant term. So there are in total 5 terms, but on the left hand side we only have a single term x squared. However, we can convert it into one having 5 terms in this fashion by writing as 0 times x raised to the power of 4 plus 0 times x cubed. We do have an x squared, so this will be simply 1 multiplied to x squared plus 0 times x plus 0. So we have rewritten x squared in terms of 5 terms, where rest excepting x squared, all other terms are 0. This is done so that when we equate both sides, we get few equations. So we'll get a plus b equals to 0. So we're equating the coefficient of x raised to the power of 4 on both sides. So on equating both sides, this is what we are going to get. Next will be b plus c equals to 0. That's the coefficient of x cubed on both sides. Next we have 2a plus b plus c plus d. So this is going to be equals to 1 because the coefficient of x squared on the left hand side is 1. Then we have b plus c plus d plus e. So that's going to be equals to 0. And then finally we have a plus c plus e. So that's also equals to 0. Now clearly we have 5 equations. We have equation 2, 3, 4, 5 and 6. So we have total 5 equations and we have 5 unknowns a, b, c, d and e. So we can solve these 5 equations to obtain each of the values. This is a very simple exercise. I'm leaving that as For leaving it as an exercise for you to try out, I'm going to state the values. So a is going to be equals to 1 over 4. Then b is going to have a value negative 1 over 4. C is going to have a value 1 over 4. D is going to be equals to 1 half, and E is going to be equals to negative 1 half. So we have A, B, C, D, and E. What we can do is now we can replace all this value back in number 1. So we have 1 over 4 divided by x plus 1 added to B, which is negative 1 over 4x plus C. So that's 1 over 4 divided by x squared plus 1 plus half x plus minus half over x squared plus 1 whole squared. So let's write it properly. Thus, the final value, so that means we have started out with x squared divided by x plus 1 multiplied to x squared plus 1 whole squared. So this becomes 1 divided by 4 times x plus 1. Then we can rearrange the second partial fraction as positive. We are going to take 1 minus x, and in the denominator we have 4 times x squared plus 1. Plus we have x minus 1 divided by 2 times x squared plus 1 whole square. Right. So this is how we have successfully resolved the given rational fraction into its constituent partial fraction, and we have 3 partial fractions here.